Beyond our shores, an ancient predator roams the seas. Older than the dinosaurs, older even than the first trees. Sharks have ruled the oceans for over 400 million years. Across the globe, one group of sharks has mastered the art of long-distance travel. They are known as the pelagics. These nomads travel over 20,000 kilometers a year in search of food and mates. They brave the desert of the open ocean, navigating a featureless blue world with pinpoint precision. From the Indian Ocean to the Pacific and the Atlantic. This elite group deploy an array of tactics to go where no other sharks can. Florida, USA. As holidaymakers hit the beach for spring break, most are unaware they share the shallows with a swarm of sharks. Oceanic blacktips. A single pack can contain over 15,000. It's one of the greatest gatherings of sharks on Earth. But why are they here? One man's taken to the air in a bid to find out.
What's interesting about these blacktips is that unlike a lot of other coastal pelagics will sort of distribute over a broader area, these blacktip tend to hang out along the beach. They're feeding on little bait fish in the surf zone, and so that's where the fish are, that's where the blacktip are going to be.
Stephen Kajura has been studying Florida's blacktips for over 15 years.
November 80, Delta altitude, your discretion, resume navigation.
And he's made an extraordinary discovery.
When we're looking at down at these aggregations of all these thousands of blacktips, turns out that they're all males. And they'll stay here for a couple of months, and then as the water starts to warm up, these sharks will migrate farther north, and they'll eventually end up as far north as Long Island, New York.
Driven by seasonal changes in sea temperatures and the innate desire to find a mate, Stephen has discovered that these male packs will travel up to 110 kilometers a day, hugging the shore as they journey north.
There are certain areas where mating takes place, and certain areas where the females will give birth. And so these sharks will migrate to their known nursery areas and then go off again when the mating is done. Consider that these sharks are about the same size as a human, not quite 2 meters in total length. It's pretty impressive that they make this migration all the way from South Florida all the way up to Long Island. It's like us walking that distance. That's a long haul.
Here in Florida, this vast gathering is a dangerous time. But not for the beachgoers, for the blacktips. A far bigger predator has been drawn to these shores. A true ocean wanderer who has crossed hundreds of kilometers of open water in search of food. The great hammerhead.
We're not sure where all of these hammerheads are from, but we know at least some of them that were tagged in the Bahamas have come across the Gulf Stream and have been detected down here in South Florida. So we know at least some of them are making that trip, taking advantage of this seasonal feast.
The blacktips know the hammerhead is too large to enter the shallowest waters. So they head to the safety of the beach. But the hammerhead is too quick. More than 20 species of sharks share the hammerhead's nomadic lifestyle. From high-speed predators like the mako to giant filter-feeding whale sharks. These pelagics crisscross the world's great oceans in search of food, mates, and pupping grounds. The rewards can be great, unlocking vast seasonal feeding opportunities. But the decision to leave the safety and riches of the shore comes with great risk. The vast blue waters of the open ocean are like a desert. In the mid-Atlantic, a solitary blue shark scours the void for signs of food. Like all pelagics, to survive here, he must be curious and bold. Anything that moves is investigated. And every opportunity grabbed. No sharks are as resourceful or as dogged as the pelagics. And no ocean puts these skills to the test more than the Atlantic. The Atlantic Ocean covers about 20% of the Earth's surface. From its frozen polar fringes to the warm, still waters of its equatorial doldrums. This is an ocean of extremes. The huge range in temperatures produce some of the most powerful storms and currents on the planet. Where these currents meet and storms churn up water from the deep, vast plankton blooms can form. These seasonal blooms are so large, they can be seen from space. This plankton attracts vast shoals of fish. And the blue shark has made a living by knowing how to find them. Every year, thousands of blue sharks leave the safety of the North America shoreline and head east, riding the waters of the Atlantic's most powerful current, the Gulf Stream. The plankton blooms the blues are looking for can be thousands of kilometers apart, forcing the sharks to cross an entire ocean basin in their search. Scientists have long been puzzled by how they manage to travel so far. The key lies in their extraordinary design. Like most pelagic sharks, their torpedo-like body shape allows them to cut through the water with extreme efficiency. Their rough skin, made up of tiny tooth-like plates known as denticles, helps reduce drag through the water. And their long pectoral fins act like the wings of a plane, giving them lift and control. This design, forged over millions of years of evolution, allows them to travel huge distances whilst expending little energy. Moving from feast to feast, the blues ride the currents right around the Atlantic, eventually returning to North American waters. It's a journey of over 9,000 kilometers. This ability to seek out and exploit feeding opportunities continents apart is key to the success of all pelagic sharks. But how do these nomads, like this giant whale shark, navigate such vast distances across entire oceans? It's a question researchers from Florida State University have been trying to answer.
Scientists have been studying the movement patterns of sharks for quite some time, and with the advent of new technology, especially satellite tags, we've been able to track the movements of these sharks across an entire ocean basin for days and days on end, maintaining the same heading throughout.
The open ocean is a vast, featureless wasteland. Despite this, migrating sharks are able to travel in a straight line, night and day, for weeks at a time.
If you think about an animal being out in the open ocean and being able to swim in a straight line for thousands and thousands of kilometers, the natural question is, how are they doing this? We know that sharks have a fantastic sense of smell, and over short distances, it's been shown that sharks can use that sense of smell to help find a target location. But for these long-distance movements, it's relatively unlikely they're using the sense of smell because there's no point source for that smell over their entire movement.
In fact, the only constant presence out at sea is the Earth's magnetic field.
No matter where you are on the Earth, the magnetic field is there. It's all around us, it's right here, you just can't see it. And the field itself varies from the poles. So each spot on Earth will have a unique magnetic signature. So to think about this in context, where we're standing now in the panhandle of Northwest Florida, the magnetic field is stronger here than it is 500 kilometers south.
Turtles, birds, and even lobsters have all been found to use magnetic fields to navigate. But until now, nobody knew if sharks could do it too. To solve the mystery, Brian built a huge cage called a magnetocube. By changing the amount of power that runs through this copper wire, he's able to mimic the magnetic field of any location on Earth. Brian then brought some local bonnethead sharks into the cube. When the sharks are exposed to the magnetic field of the location they were caught, they swim lazily round and round the tank. But when they're exposed to a different magnetic field that mimics a location about 600 kilometers south of where they were caught, their behavior completely changes. They no longer swim round and round, and instead focus all their efforts on the northern side of the tank.
They're trying to get home. They're trying to get back to where we captured them and they spend their summers.
Exactly how sharks can detect the Earth's magnetic field is still a mystery, but this ability is key to the success of all migratory sharks.
Without being able to maintain a consistent heading between locations, the sharks may not experience as high levels of reproduction, or they may fail to get to their feeding grounds or other important components of their life. So it's really critical for their long distance navigations to be able to stay on course and reach their target location.
Armed with this ability to navigate vast distances with pinpoint accuracy, and a memory for where and when food will be, pelagic sharks have spread right around the world's oceans. They exploit a range of wildly different feeding opportunities, from turtles to 10-meter humpback whales. The pursuit of each new meal presents a completely new set of challenges. How do they adapt their hunting strategies? In Cape Cod, Massachusetts, one team is trying to find out. This is the legendary home of the Atlantic white shark. Every summer, hundreds descend on these beaches, on the lookout for seals.
Yeah, hey John, I got one down here, north end of Mountain Boy. I'm circling now.
That's fantastic, Wayne. We'll rig up the tags and head your way right now.
Roger.
With the help of aerial spotters, Greg Skolmel and Megan Winton place cameras on the backs of white sharks to learn more about their hunting behavior.
The white sharks can actually tolerate a really broad temperature range. You know, they're able to move out into deep water, forage at great depths, and then at the same time, you know, a few months later, that same shark can move into shallow habitat and attack and kill a 500-pound seal. So, you know, it's a remarkably successful species in its ability to adapt to different environments.
It's 10:30 and a boat and a half. You probably see them.
To tag the sharks, Greg has to get within 2 meters of them.
Directly down, son, from you.
In such shallow water, it's dangerous work.
Oh, I see him up there. He's on the port side.
All right, let's get ready here. Yeah! Left side, left side.
That's how it's done.
Over the next 3 hours, the shark, a 3.5-meter female, moves steadily north, hugging the coast in water less than 5 meters deep. The team follow at a distance and listen for the tag's distinctive signal.
The Cape is very different from some of the other white shark hotspots that you might have heard about. So off of South Africa, Seal Island, places like that, they have deep water that they're able to kind of rocket up from depth to attack a seal. Here, what they do is slowly patrol the coastline, waiting for a seal to come out and essentially make a mistake so they can make their move. They're as much a sit and wait predator as you can be when you're a large shark that has to keep moving.
It's this ability to adapt their hunting strategies that is key to the success of pelagic sharks. Wherever they roam, they find a way to bring down prey. By late afternoon, the tiny camera on the shark's back captures something extraordinary. A lone seal wanders too deep. The shark picks up the seal's scent. Her fast twitch muscles kick into action and allow her to accelerate to speeds of 50 kilometers per hour. Fast, but today, not quite fast enough. But the team have witnessed other successful shallow water hunts, which reveal just how adaptable and resourceful the white shark is. Greg and Megan have discovered the sharks spend up to 6 months here, gorging themselves on seals. But by December, the water becomes too cold for even the biggest of white sharks, and they're forced to leave this rich hunting ground.
All the sharks we've tagged move south, all the way into the Gulf of Mexico. And then during the winter months, some of them will actually move offshore, out into the middle of the Atlantic. And they'll go as far east as the Mid-Atlantic Ridge, even the Azores. You know, why they're doing that, we have no idea.
There are few seals where the white sharks now head. What are they feeding on in the middle of the Atlantic Ocean? A clue comes from the depths. Up to 1,000 meters under the ocean's surface lies the twilight zone. Just beyond the reach of sunlight, temperatures here drop to near freezing. Scientists at the Woods Hole Oceanographic Institution have found many different pelagic sharks visit these deep waters.
We found that sharks that we thought were surface dwellers are actually making lots of dives deep into the ocean twilight zone. They're experiencing some really challenging environmental factors while they're down there. I mean, you have low light, low temperature, and low oxygen, and that's going to be a really difficult thing for the sharks to overcome.
So why do the sharks risk all to dive down here? A clue comes from a discovery made in World War II, when the US Navy were conducting top-secret sonar experiments.
They were seeing this weird band of something in the deep ocean, and they weren't sure what it was. They were thinking maybe this was just a shallow portion of the ocean and this is the bottom. But they discovered that that weird band was moving throughout different parts of the day. And the more we looked at this weird band and tried to figure out what it was, we found out that it was actually millions upon millions of organisms in the deep ocean. Sea jellies, zooplankton, crustaceans, small fish, even cephalopods like squids. There has to be a reason that you're putting yourself into these situations, and the evidence is pointing towards food.
It's called the deep scattering layer. Every night, these twilight zone creatures migrate to the surface, and every morning they return to the cold waters of the deep. The Woods Hole tagging data shows the pelagic sharks shadow their every move. Like clockwork, they swim down to feed each day. But how do they overcome the extreme cold of the deep?
Sharks are diving to hundreds of meters below the surface of the ocean, and sometimes they're using warm water or warm core eddies to access these depths. These eddies are pulling warm water deeper into the ocean, and the sharks can use that as a tunnel to forage for longer at deeper depths without getting dangerously cold.
By riding these warmer eddies, sharks have found a way to break into the cold depths to find precious food. This could explain how they're able to survive long migrations across the desert of the mid-Atlantic. This skill could be key to the success of many pelagic sharks around the world.
They're making these huge movements across entire oceans, and that's really expensive in terms of energy. Like, to run a marathon, you have to fuel yourself with so much food to make that happen, and sharks have to do the same thing. So we think that the ocean twilight zone might be a way for them to kind of stock up on energy or even recover from these long-distance migrations.
The Pacific. The largest and deepest ocean on Earth. It covers 30% of the planet's surface and contains twice as much water as the Atlantic. Its sheer scale presents a massive challenge to any ocean nomad. But the Pacific also presents opportunities the Atlantic does not offer. Over 25,000 islands break up the vastness, more than the rest of the world's oceans combined. These rest stops provide a suite of services for nomadic sharks. The remote island of Cocos lies 550 kilometers off the coast of Costa Rica. The tip of a huge underwater volcano, its steep flanks drive deep water currents towards the surface and bring with them a rich soup of nutrients. Vast shoals feed on the plankton, and they in turn offer feeding opportunities for hungry sharks. Silkies, hammerheads, and Galapagos sharks all make regular visits to islands like this, timing their arrival to perfection. On the full moon, fish gather on reefs to mate right across the Pacific. Sharks are never far behind. They bide their time. The fish rush to the surface to release their eggs. In the commotion, the sharks move in. Scientists have tracked the Pacific's pelagic sharks and found they move from island to island, using them as stepping stones to travel across the ocean. And the islands don't just offer opportunities to feed. They offer a place to freshen up after a long journey. Sharks can pick up unwanted guests on their travels. Parasites. Left unchecked, these creatures can weaken the sharks. But at the reefs and lagoons that fringe these islands, some fish provide a free cleaning service. Bold angelfish pick at the infested wounds of a scalloped hammerhead. All kinds of sharks come to be cleaned. This little gobby shows no fear of the white tip's teeth. A gray reef shark lifts its body to invite their attention, and the wrasse move in to pick its mouth clean. A temporary truce between predator and prey. With a clean bill of health, the sharks can head to sea once more. Most pelagic sharks journey around the oceans alone. Eventually, though, they're gripped by the urge to find a mate. but how to find one in an ocean 19,000 kilometers wide? Once again, islands provide a solution. Back in Cocos, hundreds of scalloped hammerheads gather every year for a mating ritual unlike any other. As numbers build, they start to swim as one. Females stay in the center of the swarm, cocooned by a wall of males who have just one goal: to seek out the largest females. These 2.5-meter giants can produce more offspring than their smaller sisters. As the shoal continues to circle the island, one by one, they pair up and start to swim side by side in a complex mating ritual. With nightfall, the pack begins to disperse as couples depart and disappear into the dark to mate. When pelagic sharks leave the safety of the shore for the desert of the open ocean, a shortage of food is not the only threat they face. Their epic journeys take them through some of the least controlled fishing grounds on Earth. No other group of sharks has suffered as badly at the hands of humans. Since 1970, pelagic shark numbers have seen a 71% decline. An estimated 20 million blue sharks are taken every year, victims of bycatch and targeted fishing for the shark fin market. Their inquisitive nature, the shark's undoing. Today, 3/4 of pelagic shark species are at risk of extinction. But in the waters of Hawaii, there's a scientist that's working to turn the tide. Here, the sea floor falls away to depths of over 2,500 meters. It's one of the few places where you can see one of the most threatened pelagic sharks on Earth, the oceanic whitetip.
Oceanic whitetips in particular, they prefer to be over deeper water. They're highly migratory and they're moving vast distances over open ocean. And so it's really hard to track them, follow them, figure out what their day-to-day lives are like.
Unlike other pelagics, they rarely come close to shore. Nicknamed sea dogs for their tenacious and fearless attitude, packs of whitetips have been known to track fishing boats for days on end. They were once the most common sharks on Earth. But today, their numbers have crashed. Their taste for tuna leads them into direct conflict with humans. As their numbers fall year on year, Melanie enlists an unlikely ally in an effort to better protect them. Fishermen.
Well, guys like me and Mike, we're commercial fishermen, and we fish out here for a living. And it's our job to know where the tuna's at.
With sharks and fishermen going after the same precious prey, there's been a history of conflict.
It's funny how it works. Wherever the tuna is, the sharks are. They always find the fish first, you know? And while we're catching them, they eat up like 90% of our fish, like literally. And back in the day, we used to just shoot every shark and catch every shark and kill them before we could start actually catching fish. It's an ahi, guaranteed. What, Mike, ahi?
Now, instead of killing the sharks, fishermen like Brian help Melanie to catch and tag them.
There's a nice shark right there. Got him.
How you like that?
Right on.
So stoked.
Take that to the bank.
You got him on the left side, I think, because he
on
turned.
his left side.
Yeah.
On his left
Okay.
side. Got him.
Did you see any?
Right in the middle of the dorsal.
Yeah, that was
Right
perfect.
in the middle, perfect.
I learned a lot from Melanie. She's showing me the data on it, and it kind of gets me excited, you know, because I get to see where my shark went, you know, that I tagged.
They've been very, very good at getting tags out for us. So we have something like 75 oceanic white-tip sharks tagged at the moment. And I think I only tagged like 5 of them. Most of them was the fishermen that we have trained and doing the tagging for us.
But you really got to think about it like this. I mean, this is their home. This is their house. You know, they don't come into your house and shoot you. You know what I mean? So we're trying to coexist with them. Trying to figure out ways to be able to catch fish and preserve the sharks.
Every few months, Melanie checks the listening stations that line Kona's shore. Every time one of her tagged sharks passes within 100 meters of the station, its ID number and the time and date are logged. This data helps Melanie piece together the movements of this mysterious and beautiful shark.
What we're learning is residency information, but also arrival times and departure times, because we're trying to figure out if there's any sort of predictable behaviors that the animals are exhibiting so that we can kind of inform fishers on how to avoid them. Is this a mating area? Is it some sort of an aggregation site for the species? We're hoping that with another year of data and additional animals tagged, that we'll actually start to see the kind of patterns that we're looking for.
With the fisherman's help, Melanie is revealing how the shark's movements are closely linked with the tuna and how they can be better protected. But her research has unveiled another strange twist.
In Hawaii, one of the things that's super interesting, because I don't know if it's been documented anywhere else, is that oceanic whitetips are often found in association with short-fin pilot whales.
Fellow tuna hunters, pilot whales, use echolocation to find their prey. Could oceanic whitetips be shadowing the pilot whales, waiting for them to make a kill?
Pilot whales are kind of sloppy eaters, and so the oceanic whitetips, they can get little scraps because the pilot whales tend to share food, and so I think that motivates the oceanic whitetips to stick around with those guys for a little while. I think that they are really good at being opportunistic and exploiting whatever opportunity kind of comes their way.
On the other side of the globe, the nomads of the Indian Ocean face very different challenges. This is the warmest of the great oceans. The high temperatures limit the growth of phytoplankton and severely affects the amount of marine animals this ocean can support. From the wild cliffs of southern Africa to the remote reefs of Western Australia lies almost 9,000 kilometers of unbroken water. With so few islands and a lack of food, the sharks of the Indian Ocean have to work hard to find a meal. Off the east coast of South Africa, a 3-meter tiger shark has detected a curious odor in the current. Like all pelagic sharks, she has an acute sense of smell. It takes just one molecule in a million for her to change her course. Following the trail upstream, the scent grows stronger. Now, cells in her nose can detect the microsecond delay it takes for odors to reach one nostril before the other, allowing the tiger to zero in on her quarry with incredible precision. She's hit the jackpot. A rare feast of whale blubber adrift in the ocean. And she's not the first one here. The fat beneath the whale's thick skin is one of the most energy-rich substances on the planet. A single kilo provides over 8,000 calories. Using their teeth like hacksaws, the sharks tear chunk after chunk out of the whale. Normally lone hunters, tiger sharks put up with the company of others when there's a bounty like this. Gorging until they can eat no more. A single whale fall can keep a tiger shark fed for weeks. The Indian Ocean is home to over 30 species of whale. Like pelagic sharks, they travel vast distances in search of feeding opportunities. And off the coast of Australia, scientist Mark Meekan has found their lives are closely intertwined with those of sharks.
For a big oceanic wanderer like the tiger shark, the ability to scavenge is just as, if not more important than their ability to hunt. Now, these animals are living in warm water, and those waters don't have a lot of food in them. So you've got to be able to scavenge to make the most of your environment.
Every year, over 30,000 humpback whales migrate along this coast. And Mark believes a range of different pelagic sharks pay close attention to their movements.
So of that population that's moving up and down the coast, we think around 60-odd animals are dying each year. The appearance of a whale carcass is just a huge opportunity for these animals that live in this low-food environment to basically go crazy. And they do. Pretty much every pelagic shark faced with the food bonanza of a whale carcass will get stuck in. It's really important, we think, for their survival out in these open ocean waters.
Despite the challenges of finding food in the Indian Ocean, once a year, it plays host to one of the biggest feeding events on Earth, revealing a little-known side to pelagic sharks not witnessed anywhere else on the planet. Every winter, off South Africa's east coast, a remarkable event unfolds. Hundreds of millions of bait fish are swept north on cold water currents. Trapped by the land on one side and warm water on the other, they form dense black shoals, some over 15 kilometers long. It's the annual sardine run, and it's thought sharks will travel incredible distances just to intercept it. Blacktips, spinners, and copper sharks form one of the greatest gatherings of hunting sharks on Earth. On their own, the sharks would not be able to catch such small, agile prey. But if they work together, the tables are turned. Over 300 sharks push the fish up from the depths and attempt to trap them at the surface. The terrified fish form a huge bait ball the size of a house and begin to move as one. With the sardines tightly packed, the sharks move in. They gorge themselves until they can eat no more. It reveals a rarely seen, cooperative side to shark behavior. Soon, the glittering sardine scales are all that are left. The sardine run lasts just 4 months. For the sharks of the Indian Ocean, the bounty is over. They return to their solitary lives. Around the world, migratory sharks have carved out an existence riding the ocean's great currents. They are the largest, most adaptable, and complex of all sharks, but also the most threatened. In addition to fishing pressure, rising ocean temperatures are changing ancient currents, forcing sharks to find new feeding, breeding, and pupping grounds. Will these resilient predators be able to adapt once again?